All right.
Okay, go.
I lived here for 12 years before, but this is the first time I'm speaking here, so it's very exciting for me. It's coming back home. Can we see the slides?
Did it turn on?
I'll talk a little bit more. So I immigrated to this country from Turkey, and this was the first place that I've been to, and I worked in so many of these coffee shops and restaurants around you, and here I am. So tip your servers so they can study a little bit more and become, software engineers. It's a good thing. I am a Google developer expert now for web technologies and specifically for Angular. That makes me one of these cool kids. And that means that you can reach out anytime to ask questions through Twitter, and we are here to help the community. And when you have some problems, we are here to direct that to the Angular team. And I just want to, since this is not coming out, I just wanted to tell you a little bit about.
What's that? Can you see?
It's not sleeping. Turn it off, on, no. Oh. All right, I start talking about it, so I'm going to finish. So just one thing I want to tell you, if you think you can speak at ngConf, you have nothing to say, just think about the last time you were like Googling things about Angular and not finding the answer you're looking for, getting stuck in place, and you find it out. That means that you have something to talk about. Really, it's pretty much everyone, right? I mean, it's pretty new. Everything is pretty new. We have very little resources out there. We have very little information. So if you spend some time figuring out something, that means that somebody else needs to learn about it. Just think of that. So I work with Narwhal. I just recently joined. We are a consulting company. Basically, we focus on making the developers a little bit more productive, especially building large applications. Founders are two of the core contributors. You might know them, Victor and Jeff. And myself and Justin, who's also doing Angular Air, you might know him too. So it's a really cool team.
Can you reshare your screen on now?
Mm-mm. Let's see. Can everyone hear me? Is it on? Yeah.
Yeah, you need your speaker. I have mine on.
Okay. So, addition to just, giving consulting and also some workshops, we have a new library that we just announced at Angular Mix. What we do is to try to make you a little bit more efficient in building large-scale applications and having a much easier build process with multiple applications and multiple libraries that you might be depending on, and make NGRX store usage much easier. Basically, we're extending Angular CLI, making it more useful for bigger applications. How many people use the CLI? Oh. How many people use NGRX? How many people have a lot of data and state to manage? Oh, maybe I should ask, like, how many people are using Angular? The latest one, Oh, approximately half. And we also have with transitioning from Angular 1 to Angular 2. So if you are interested in looking at the slides, they're at bit.ly and Three.js, and GitHub repo is there, and we have a live demo towards the end. Oh, I should stay there a little bit longer. So what I want to tell you about today is talk to you about the terminology a little bit. How many people really seen an app with augmented reality or like really familiar or work with it? Yeah, that's great. I think it's one of the really exciting technologies right now, and it's cooler than WebVR. About WebVR too. So I will tell you a little bit about the mixed reality terminology, what I mean by it, and talk a bit about WebGL API. That's what we use to create these experiences, and what makes it really interesting to use it with Angular. Obviously, that's why you're here. And I want to give you a little bit more about the different libraries I tried and where you can go from here. So reality. I need an exclamation mark there, right? So reality is where the boring meetings happen. You know, your coworkers constantly ask you to do something, and like these meetings never end. Like you just wanted to, it's hard. It's not a good place to be. So this is the best time for anyone who wants to run away from their reality and create like imaginary friends and like imaginary like forget all about it. It's like you can do it anywhere, anytime you want. And it's totally immersive, and you get lost in it. And your coworkers don't really agree. So virtual reality is the other end of the spectrum from reality, what we have today. And virtual reality is completely immersive, you create your own world, and you have to define everything in 3D, and you get lost in it. And you need some kind of a device for it. Augmented reality is somewhere in between. So basically, we have our everyday life, and then we can extend it with some information, 3D objects or maps or visualizations, whatever you like. So I think it's very interesting because it's not completely cut off from real life, and then it has so much more applications. And I think it's going to be much more widely used. That's where we are going. So the general term that we use for all of these things is mixed reality. Some people are trying to call it XR, but it's really hard to Google. So hopefully that name won't stick. But overall, the APIs that we are using are all the same. So they're being defined right now, and all of them are very, very experimental. So that's the warning sign. It's very usable, but they're experimental. So it's just like using Angular beta when it was in beta. Anyone did that? Yep, you know what I'm talking about.
But more fun.
More fun, yeah. Everything changes very rapidly, but there's a conversation out there. So if you're interested in this, please join the conversation, which is happening on GitHub. Now defining how we are going to have these APIs. And it's been called WebVR APIs, but AR is going to use them all together. So it's basically going to be mixed reality APIs. The other thing that augmented reality specifically is using, not the WebVR, is media stream. So what we are doing is taking your camera and streaming your camera data and then rendering things on top, which is great, but not available on iPhone. So is made available right now, but I heard that it's going to happen sometime soon, hopefully. If you would like to see more of the demos, they're really cool. If we have time, we can look at it at the end of the talk. There are 2 different websites for desktop and mobile, and you can also look at Three.js libraries VR examples as well to get inspired. So what is WebGL? Anyone who works with WebGL? Yay! Three? Did I see three? It's the most popular API on the web. So it's a scary place for so many people. So that's why I'm doing this talk. Hopefully you won't run away. I come from a 3D world. I was doing animations, 3D animations. So my first JavaScript project ever was using WebGL APIs to create 3D stuff because I was very comfortable with it. But I saw all of my friends just looking at it and saying like, oh my God, what are all these terms? They're like, they just wanted to run away, really. And my purpose here is to introduce you to these concepts so that they're not super foreign. But the usage itself is not that bad, really. It's pretty clean. And it's pretty much supported everywhere right now. It wasn't for the longest time on Safari, but it's available everywhere now. And why is this important? Why am I showing you this? It is very important because having the availability on the web makes it available for so many people. It's so hard for us to understand, but maybe because we have these really powerful phones, all of us, and we are able to just download any applications that we want, but it's not the case for everybody. So being able to publish something to the web makes it available all around the world. And also, it's kind of freedom of speech because then you can create any content that you really wanted to create and you're not stuck in any app store. So WebGL is an amazing API that allows us to create 3D or 2D graphics on canvas. And it has access to the GPU, so it's very powerful and it makes it really fast and you can do so many interesting things. But it's really hard to write. I mean, really, it's long. Something that you write for like 300 lines of code or 200 lines of code, you can do it with Three.js, which is a library built on top of WebGL and allows you to use simple objects and create your scenes through them. There are other libraries, obviously. Three.js is the most popular one, created by Mr. Dupe, who's amazing. You would see him answering all these questions. And it's being used by many big companies. I work for Autodesk. We were using it. I know Google is using it. So many big companies are using it in their production. A-Frame is a new one. Have you heard of it? Yeah, A-Frame is being developed by Mozilla. It was just two people team. Now Google is pitching in. They have some developers working on it. It's very much like Angular component based, but what you write is an HTML. You have these components, but you are still, you are not really working with the JavaScript, but you are just using the components in your HTML. But it's a very interesting thing, and you can, it works with everything, with React or Angular, anything. But I really like using Three.js and working with the WebGL APIs directly with Angular, because Angular allows me to create my own components and create them as I really want. I really like A-Frame, but it creates a lot of HTML and I know that it's not being used, and it just didn't click with me. But it's a great tool, especially if you are starting up, because it's very, very easy to use, and they have great documentation. But I will show you how to create your own Angular components today and services. And in a way, I mean, the point for me is that it fits perfectly in any kind of application. And if you're wondering like what we were building, at Autodesk we had basically every kind of application that you can think of, but in 3D. Like we had 3D slides, 3D documents. And so we have all these state management, we have all these other stuff that we are supposed to do, deal with authentication and everything else. On top of it, we have to work with WebGL. So it's a perfect case, because Angular makes managing your state and part of your application much easier. And reusability, you can create your components and reuse them anywhere, anytime, over and over. So it's deliciousness. So I mentioned there are multiple libraries that allows you to do WebGL. Why Three.js? First of all, it's open source and there's a huge community behind it, and the examples are great. But also, it's really much faster to write. Instead of 200-300 lines of code, you can do it much faster. So it's really nice. It's really easy to learn because if you got the basic concept, it's just objects, very well named, and then you're just working with those objects. You're just using their methods and not really worried about the implementation detail. And it is really fast. So this part is really important because animation is a totally different beast in a way, because I mean, we add and just subtract things from our DOM, and it's very expensive. We know that, right? Re-rendering things on the DOM is very expensive. And when you have an animation, when you have 3D objects, you are constantly doing that, basically 60 times per second, hopefully, if things are going well. And that means that your rendering functions has to be very, very, very optimized. And that's what Three.js is doing for us. So it's really optimized. And I've seen so many people who, like, I worked on one rendering engine, and it's a hard business, and Three.js is doing a great job. So these are the concepts that we have to know. They're not very scary. Did you have a question?
It's stupid, but is there a different DOM for each eye?
I'm sorry?
Is there a different DOM for each eye? Or?
Great question. It's a camera. It's a different camera. There are two. Normally, how it's done in real life too, like you can have two different cameras, and we have a specific camera that renders differently. That's all.
So there's a 3D DOM totally independent of the DOM, and it has 3D objects and then camera objects.
Oh, I see what you're saying. So what creates the image is inside the canvas. You have just a regular DOM and a canvas element, and everything that you have with Three.js is created inside that canvas. So it's in one place. But I thought you were asking for WebVR, like the 3D glasses. So that's done by the camera. Different camera. But maybe towards the end it will be clearer. But if you have the question at the end, please ask again. So all of these concepts, 3D concepts, are coming from movies or cinema or anything that's kind of real life. Just think of yourself as a set, as the production, not designer, producer of a movie. So what you need first is a scene. So you can yell out scene. It's just one object that you attach everything into. So we know what we are working with, what we are rendering. So this is our stage. So this is where I am. And we have a camera that controls our point of view. So we have all these 3D things around us, right? And we have to render it into 2D DOM. What we do is, how we control it is through the camera. So we look at a certain place and then we define how much of it we do see. Another analogy I really like is photography, right? We used to take pictures and then like we cut some parts of it, like we focus our viewer. And we have a renderer that takes our point of view and takes our scene and then renders it to the 2D environment. So in the film, old film photography analogy, it is rendering it to the actual film, basically, or to a paper, right? We are taking the 3D information and rendering it into a 2D space. So a scene is an object. It's a simple JavaScript object that we initiate. And then, well, everything is an object, right? Camera is another object that takes some parameters. First one is field of view. So that defines like how much of the field that we are seeing. This is the default. And the second thing is that you match it to rendering. So in this case, I'm using the whole window, but it might be just a div that you're rendering into, and it should take the width and height of the div. The other thing that this is very important is the quality of the image. So this is like a film, right? So this is defining how many pixels you have, basically. So if you want to render faster, you can also define a smaller aspect ratio and still render it into the same canvas, so you will have less pixels. The third and fourth arguments are near clipping point and the far clipping point. That defines the anything, in this case, 0.1 means 0.1 the camera. Anything further than that, I will render. And anything before 1,000 units, I'm going to render. That allows us to do two things. We can define kind of an area that we wanted to leave out. That's important because we might have endless number of objects in our scene, and we usually don't want to render all of it. It's very heavy. So we can control that this way. But at the same time, if you think you have one object and you can't see it, just check your near clipping and far clipping points as well, because it might be out of reach too. It might be before or after these limitations.
Quick question.
Yeah.
So this is all happening in the browser.
Right? Mm-hmm.
So the Three.js library is able to get the inner width of the windows automatically?
No, that's why you were giving it. That's why I'm mentioning it, because you are defining this. This is just the 4 parameters that the camera camera method takes, perspective camera method takes. So you are defining it. So if you wanted to render a less quality, you might want to change that to a smaller number. But in this case, you're basically, the aspect ratio is important. So just keep that in mind. This could be any width or height. But it should be the width or height of your container elements, basically. And we have the render. As I mentioned, render translates things. It basically is the artist that looks and sees whatever and then draws it to the paper, turns 3D things into 2D on our DOM. And it also takes this size, and this is also important for the quality of it. And we attach that render to the DOM. So 3 things, approximately. We have a scene, we have a camera, and we have a renderer to start doing some stuff. And this is what we get. No, I'm not lying, it's true. Because we haven't defined any objects. I mean, in this world, we don't have much choice, right? I mean, this is the reality we go with. But in 3D worlds, you are creating it, you are the creator. If you haven't defined anything, there's nothing. So the reason there was nothing is because we don't have any objects. Objects are interesting to define. So it needs 3 things. One of them is the object definition. So what am I? Am I a cube? Am I a sphere? And the other thing is the material definition, which is how we see things. It defines how light reflects off of things. So that's how we see. If there is no light, if you can't perceive your any lights, you're blind. Everything is darkness. So the way we see perceived light reflection defines everything that we can think of. It defines the material. It defines like the smoothness and the feeling of it. It's really a very powerful tool. It also defines, well, not in real world, but in 3D world, you can also define it to define how far an object is and how close it is, and give it some depth. And the mesh is what puts it together. So I defined a material, I defined a geometry, which is a sphere, and how do I know which one goes with which one? Because in normal scenes, there are tons of them. We put them together. You could think of the mesh as a group object. This is how we put it together, mesh it together, I guess. So we have a bunch of objects that are predefined for us by Three.js. Box geometry, it creates a cube, and it has width, height, and depth. Obviously, different objects have different parameters that you need. Documentation is there. Well, I haven't checked it so anytime recently, but what I want to tell you is source code is amazing. I mean, I told you this is the thing that I used in my first ever JavaScript project, and I was able to read the source code. It's very easy. And then just download the library and just look at it. If you're curious, it's very well defined inside the code. And there are tons of examples. That's the other thing. There are tons of examples that you can take a look at. Let's take a look at it. Oops, broken link. All right. So all these are these amazing examples, and most of them have a view source link that you can just go and mess around with.
Those values that you find, those are relative to the aspect ratio.
That's a good question. Well, they're their own units. I mean, I know that they're not centimeters or anything like that. You can map to it.
This sort of maps to real world units like meters or whatever. So like 1 unit equals a meter in the virtual space. At least that's OpenGL, right?
Mm-hmm. Yeah, I mean, we are not doing a perfect job with JavaScript, right? Translating things, but that's true. I mean, it's I'm actually not sure. Like, I don't think it's translated directly to centimeter. Does it? Do you know?
No, I think that it can be arbitrary, but I think that the units map to like real world units. So in the virtual world, a unit would map to like a meter in the real world, something like that.
Yeah.
That's where you get your in OpenGL. That's
In frame, the units are meters. How they get there?
Those Europeans. Or the rest of the world. I don't know. It's not just Europeans.
that metric system,
But I don't think it's related to aspect ratio, because aspect ratio is not defining the distance, it's defining the 2D. It's kind of like your paper when you're printing a picture. So it's not the depth, it's not related to the depth. But good question. So we have also the materials. Materials are really hard if you're trying to write for yourself and shaders, because it's these reflection and refraction calculations and all that stuff. But it's so nice. There's so many shaders out there, and there's so many basic shaders that comes with Three.js. And also there's so many out there in the whole world that you can download and use. In this specific case, we are just giving a very basic material that doesn't have anything special. It's usually a very matte, not very reflective surface. And then I'm defining some color. But if you have a very basic material, you can also define more stuff. You can turn it into anything you want. You can give the texture that you want. Also, this mesh depth material is defining kind of the depth. What it does is it pre-calculates the shadows, basically. So it is getting the shadowy information, so it doesn't have to calculate it from the light, but it wraps it as a texture. It's kind of like a cheat. As I said, everything has to be put together inside a mesh. That's the grouping that we have. We define the geometry and we define the material and then give it to the mesh method, and that creates our cube. Once we have our cube, we have to add it to our scene. The scene object is, you remember, holds everything together. If it's not on the scene, you're not going to see it. That means it's not very important. And so sometimes you do have the scene, you do have the object, everything you think is fine, but then you don't see anything because as a default, everything is defined in the very middle. Everything is defined on 0, 0. So that's why you can't see it. Everything is on top of each other. So make sure either move your objects or your camera away so you can look at the objects from the camera. So put it all together. We have the geometry defined. We have a material. We add it to the mesh, and we call the cube and add it to our scene, and then move our camera. Now everything is ready. We have our scene and we have our objects. Then we have to render it. And rendering happens through one function that runs over and over, 60 times per second, hopefully. The hopefully part is that usually, well, sometimes things are heavy, it takes longer time, and that's why it's very important to use the request animation frame function. Has everyone used it, or anyone haven't used it? It's a very useful function, but it's not used as often as it should. It doesn't only, it's not only useful for animation or 3D, it's useful for everything else when you have to render your DOM over and over again.
That's the JavaScript request.
Yes, it's a native method. So what it does is it knows when the DOM is going to re-render, it knows the cycle of it, and then optimizes it for you when to run the things, and when things are not smooth, when it has to go less than 60 frames per second, it smooths out things. And the other thing it does is that it saves your battery. When your user is looking at another tab somewhere else, it stops everything and doesn't run your rendering function over and over again. If you have some animations that you want to run, this is also where you put it inside your rendering function. Here we have a rotation. It works pretty much like the CSS. You keep adding to it every second, 60 times in this case. So you probably won't have something as simple as this. You might have a function somewhere, and then you would put it inside the render function that calls itself. Another useful concept about the animation is grouping. So it's, if you have a car, if you want to animate it from one spot to the other, it's really painful to animate each tire, each door, one by one. So group allows you to add things together and have one animation or one transformation attached to it. Oh wow, I just realized I forgot a very important part of it. I know how this got lost in my slides. I'm sure it was there. So the other thing that we missed out was the lighting. If you don't have a light, you still have darkness. And light is another object that we initialize. We have a bunch of them. You can add color to it. You can control it with how far they are. It's very much like the real world.
So it's lighting, because it does mesh, we can control the shading. So is that also a little bit of lighting coming in from the mesh control?
Mesh is, well, actually, that's a good question. You can probably add it to the mesh. The lighting is added to the scene because scene is your stage, and mesh defines your object. I'm a mesh, for example, right? So the material goes in here, and the shape goes in here, but I don't specifically need a light. But I mean, there are cases that you want to attach a light to an object to define something like the actual lights here, right? And why the Angular components? So what do we want? We don't want to define these things over and over again. It's so cumbersome. It's so tiring. And you don't want to remember them. Look, I mean, I forgot the light. We have nothing. So we want to make it easier on us. So we create some components or directives to define our whole scene. So we can have a pattern marker. Doesn't make much sense right now, but it's the marker that we are using for augmented reality. That's why it's weirdly named. We can have the component or the directive, and what makes it reusable is the attributes that we define on top of it, right? We can give a model to it. We can define, I don't know, maybe the lighting or anything else that we wanted to give. That makes it very reusable. Other things that we wanted to care with, I mean, why we care about using it with Angular is that we don't want to deal with the touch events and the interactions and other state management through Three.js or anything else. We wanted to do it integrated very well into our rest of our applications. And lastly, to be able to render it outside of our browser or do some pre-rendering like the Universal. I'm sure you heard of it. We wanted to use Angular APIs. We don't want to directly manipulate the DOM. We wanted to use the native Angular APIs wherever possible. So no attaching to the DOM directly and use the elements. Well, this is the directive syntax that we can define as an attribute, and we can create our component. We have the pattern marker component, and we have an input as a model. Here it's a string, so I'm just predefining what it will be, and then have kind of like a switch statement that defines the rest of the object. But also, I mean, you can think of it as a service of multiple objects, and you can you know, have pre-made ones somewhere and then wanted to define that there too. And we are dealing with the click events. And finally, on our init function, we are initiating our AR environments or ARC. So this is the difference between the A-frame, the way the A-frame does, and then the way I usually end up doing, because I think it's just a bunch of functions that Three.js is giving us, and we can just wrap it into a service and then reuse it there. But there's not just one use case, so I'm really curious, like, how you would use it. I think just having separate components is more useful. Just let me know. I think one case that's very useful is working with designers. I think it's much easier to just write HTML, but if a developer is defining most of it, I find using a service much more useful.
Good question. I was just wondering, I'm not in the Angular world these days. Can you just elaborate a little bit more on the service connection there? So you're tying it to.
Thank you so much. I'm just assuming everybody's using Angular. And Angular, the latest one. If you have any other questions, please do let me know. So Angular services are singleton objects. You define any kind of repeating functionality that you have inside a service, or you want to manage your data through a service, not in your components, because components are reusable. That's great, but also they do get destroyed if they're not in the view. So having your commonly used services, which the ones that I described, like the creating the scene and the cameras and the objects, if they are inside the service, you can just insert it through in your constructor, and then you can use any kind of functionality. And I will show the functions inside the code. It's in the demo.
Quick question.
Yes.
Are you able to, with Three.js, to load like a 3D model
Yes.
already?
Yes, that's a great question. Yes. The models extension is very important. There are so many exporters to OBJ, and you can definitely import an OBJ. But be careful with that. So, I mean, it's so nice to create these huge, amazingly detailed models, and there are so many of them online available, and you really wanted to use them inside your application, but they become really cumbersome and really heavy, really fast. So simplicity is means performance in this case. So this part is where the augmented reality starts. What augmented reality is, as I said, extending the reality, and it's using our camera APIs. And there are multiple libraries to do that. This one in particular is JS AR Toolkit. It's wrapping AR toolkits created by Apple, I believe, into JavaScript, and it's using end scripting. And it's obviously use it with care, but this was so it has some functionality for permissions to read, and then it detects our patterns that we are looking for in the real world to render the 3D objects or any kind of information that we have on top of it. And it's using Three.js as well, internally. So this is the sad scene of user. We don't really have access to it in Safari. And I didn't know this, but even if you're using Chrome on iPhone, that's apparently using Safari underneath, so it still doesn't have the access to it. How many people have iPhones? All right, yeah, you're not going to be able to see the demo. But I'll show it to you. All right. And what we do is, so it's access my camera, and then I have a marker. You see it? Yeah. Wow, thank you. So this is really magical. I mean, you can print out these things, right? The hero images, and put it anywhere you want. And you can also define your own hero images. It's not just this specific one. But the important thing about this is that it's looking for the contrast. So it's looking for the edges to define where it is in the 3D world. So it's mapping, it's basically learning according to that. And then you can attach anything that you want. You can control how far it is. And you can add animation and then interactivity on top of it as well. So everything is on GitHub. I don't want to go over the code so much because I know it's really hard to read the code or understand it. But basically, what we have is the pattern marker components, and it's has some options. You can give different models, different renders, rotation targets, or things like that. And the important parts that I mentioned, I never do want to use the DOM API directly. So in my HTML, I believe there is a canvas element. Normally, we do attach the canvas, but we have in our template we just have a plain canvas, and then we are interacting with it through the Angular's API, which is the view child here. So my view, which is my component, the pattern marker component, has a child, which is a canvas element. Let me show it instead of saying it. It has some events defined on it, so click event is defined and window resize is defined. And view-child annotation allows me to have access to it, not only when it's inside the DOM, but it's when it's not inside the DOM before we actually render it. And I have all of those functionalities that I have mentioned before inside my service. So that's where I'm defining the model, the shape of it. And I also have another service that's using the kind of wrapping the JSAR toolkit library. And I'm defining my callback. When you have access to the camera, when you have access to the user media, this is what I want you to do. And this is we can define the animations, interactions, or anything like that inside the components. But anything that's repeating, like the Three.js parts, creating the scene and things like that, we wanted to be doing that inside the service. And the way we define what we are looking for in the world is through the JSAR toolkit. So we have a load marker function. So I'm giving one specific hero image, which is inside the assets, which is the one that I was pointing to the camera. But you can define different ones, and then you can have multiple ones having different objects in one scene as well. And other interactivity goes here, like the resize and all that good stuff. So I don't want to go more into the code, but if you have any questions or if you wanted to see specific parts, I'm happy.
Do you have to have a hero image to render?
Yes, but yes, but. The but is you can use a location. I don't know how well it works. Yeah. You can use a specific location.
So I'm just wondering what the advantages of going through the Angular rendering cycle, because it's looking for 60 frames per second.
Mm-hmm.
You know, wrapping it in an Angular component just adds one other layer of problem. So wondering, yeah, using like some type of state container with these vanilla-ish, maybe something web-based.
Yes, great question. So what Angular does is use this thing called zone, right, to check what changed in your scene, and then constantly tries to see what else has changed and what it should be changing. And this is a very good use case of using zone to render things outside Angular. So I've seen people doing that to create kind of like two-way data binding, kind of like make Angular what it used to. You know, there's very bad use cases of Zone.js, right? But this is a very good use case. You can run it outside of Zone you can have your rendering outside of your zone.
So
Great
just-
question.
So thank you. So just to be clear, you're not really leveraging the Angular rendering here. You're bypassing it and
Yes, only inside this component though. So the advantage there is, so if you have a data coming through an interaction, for example, from a different component, from a parent component, you are taking the input and then the rendering is done only inside the canvas, because canvas has its own life cycle and it doesn't have, it just has to be there. It doesn't have to interact with anything else. Hi.
So to what extent, so you have the whole demo with image to like some other image. To what extent you have support for like interacting with things that aren't like defined as like this hero image?
Interacting. So are you talking about like the 3D things that we are creating?
Like you can definitely move the image around, right? And have that object when you like interact with the object anyway, or does it require like the use of like some like predefined image to like tell it, oh, this is where stuff can be, this is where stuff is touching?
So I'm trying to think. So basically, the object, the hero image that I'm having is trying to understand where things are in 3D space. So it's defining the plane, basically. And then you are attaching things on top of it. So basically, you can on top of it. We have very simple sphere, but you can have all these like 3D graphs, for example, right? And then everything else that you are interacting with 3D objects that you created in Three.js. So you are able to interact with those 3D objects, but there is no interaction with the rest of the real world. Does that make sense? You are interacting with the part that we created with our code, which is the Three.js part. But
So I guess what I'm trying to say is if you have to say
not your slide.
change, like if you wanted to detect whether or not like finger was near the object, you have to like figure out how to find out whether it was your finger and like see if it was directly yourself. Like it's not like
Oh, I see what you're saying. We are not directly touching that object, but we are actually interacting on the surface of our like phone or with our keyboard or whatever, right? But there's another but. People are working on it. Obviously, there's a cube. So there's this thing called, I have it to Verge, maybe? I don't know. So basically what they did is to have hero images or like things that describe our AR space on every surface of a cube, right? So when you turn the cube, you're still looking through a camera. You're not just looking at it and seeing things. You still have to have user media to attach it to. But when you turn it and do things, it is interacting with that. So it is pretty cool, but it's not like directly you're doing this and it's happening. Oh, but that is also possible. I'm sorry, I feel like you have something to say. That is also possible. Things like, what was the thing that detects hand? Link motion. Yes, it is possible to do it through link motion.
That camera can start finding access to real space without the hero.
Yes.
So HoloLens and the Tango technology has the depth camera, so it actually scans the room now as a physical space that it is. So you get much more precise layout of your objects. Sorry.
Yes. So yeah, that's the difference. The HoloLens, how much is it? Like $3,000, $4,000? I don't know. It's doing really intense image processing and machine learning, all that's an amazing tool, but it's not for everyday use. So this is happening in the browser and it's possible with everybody's phone and it works great. So that's the thing that we are dealing with right now. But as far as I know, Google just announced an API that they have been using for Home Depot to find things. Like it just shows you where things are. But I think it's also daydream. It's using still daydream, which is that's another device that you have that has more powers. So with image processing, machine learning, all these great things, we are able to do these things. Like, even without these technologies, like with your camera, you can get a lot of information and you can have a lot of interaction with your scene, but it's not there yet.
So with this thing at the moment, it doesn't have any depth, right? It's always like it sees the mirror image, it's going to just know it's always like the same size.
Oh no, it'd be smaller if you move it away.
Oh, it's the size of the mirror.
And the orientation of it too.
Yeah, and also you can make things bigger or smaller. It is very possible. Or with the interaction too, you can define how big or how small you want the things.
But again, it's a new thing. I guess you can say that if the mirror image is smaller and smaller, so it knows that it's smaller.
We can try, right?
Yeah.
Yeah, it looks like it's getting bigger and smaller, right? Yeah.
And then if you tip the camera, doesn't it almost like show above the hero image? Like, that's right, yeah, until it loses track of it. But
yes.
It's,
also, I feel like it's extra hard with a surface like this because it has reflection.
yeah.
So it is thinking some parts are white when it's not. Yeah. Sometimes when I was doing this, I would move fast and then it would be on my head for a split second because my hair is darkened and I was like, yeah. Hi.
So you can make your own merge cube, print it out, 6 euros.
Exactly. But you can pay them. I think it's $20 or something. But you have to have the Verge glasses that goes with it, which is really cool. It does both AR and VR, and you just slip in your phone, and it works great. And it's one of the most accessible. Like it's very cheap compared to the rest of the stuff. Yeah, exactly. You don't really need a goggle. Any camera is all you need, and a browser. Hi.
So with ARKit and AR core that we play on horizontal position. With this, is there
ARKit is doing only horizontal.
Yeah, it can only scan like horizontal.
Oh, that's interesting.
Which is why, in all the demos that are doing it like on the table.
It might be because of stability, because it's harder to detect moving objects to start with, and you really wanted to see the edge. And I actually printed out my hero image to bring here, and then it got like squished in my thing, and it doesn't work when that happens. So that might be the reason. But this is what I'm using. Yeah. JS AR toolkit is a wraparound AR toolkit, as far as So I think it works pretty much the same. But they are not even paying much attention. There is not much contribution to it, but it's been around for a long time. I mean, AR has been around much longer than we think. Yes, not very popular, that's all. Yes. Hi.
What is the most use case you've seen? It seems like
Yeah. It is really nice. I don't know, maybe Verge AR had some demos. There's just so many use cases. I mean, people do kind of visualization so much. I think it's a great educational tool, right? You can have these markers in so many places. Oh, look. Wait. You can cheat. So the thing is to learn what's out there, right, through your camera, and then map things on top of it. So it's possible to teach other stuff. So the coolest thing I've seen, I mean, somebody just tweeted at me. I will tweet it after this, retweet it. Is there was a piece of paper with Excel sheet of data. You basically do this, and there's a graph that comes off of it. It takes the data from that sheet, and yeah, I don't want to go through my tweets now, but I will tweet it right after. I thought it was so cool.
With that follow-up, right? So geocaching, once in a while. So back to the whole eventing. So I was curious if you get to either it's a geographic location or you do an image with the eventing that you have, could you then either have a recording, play, or give some other information as a follow-up once that image has been viewed? I'm not sure if that has to be tied to a geographic location as opposed to if anybody sees the image, then something else happens.
Yes, you can say, you are my only hope. No, you can definitely have a hologram of yourself anywhere and say, you can project video and you can project information. That's why it's really cool. I was saying it's very important for education. Our brains are evolved to process locational information. So if you ever train to do a memory championship, which I did, but what you do is to create maps in your house to remember things, because it's so powerful. You can't just decks of cards in random order. You can remember them really fast. And this is what we are going. This is where we are kind of emerging with AR. You can have information in interesting locations, and it's so much easier to remember. And it's kind of like you're working like your brain, right? The interaction becomes very much like your brain. You see something, and then you have a related information. This is how the information is supposed to be for human beings, basically. So I think it's really cool. Yes. I will be around, sticking around. Thank you for having me. This was a lovely meeting.